This is the introduction to section 1.5, which covers exploring angle pairs. Now, in 1.4 we talked about angles, and in this section, in part 1, we're going to talk about specific types of pairs. So we're going to take angles and put them together and discuss kind of what they mean and how they are. Okay, so again, the objective is to identify special angle pairs and use their relationships to find angle measures. So there's 4 angle pairs we're going to talk about, and these are the 4 angle pairs that we're going to talk about. We're going to start with adjacent angles. Okay, adjacent angles are two coplanar angles, so 2 angles in the same plane with a common side, a common vertex, and no common interior points. Okay, so adjacent angles, essentially, what happens with adjacent angles is if you take an angle on the left and you take an angle on the right, and then you put them together and they share that one side. So as you look at this angle right here, you see this is angle 1, and this is angle 2, and they share this middle side. Same thing over here, this is angle 3, this is angle 4, and they share that middle side. One key is they never overlap, which is what that last part talks about, where there's no common interior points. So you're not going to see an overlapping angle. So for example, angle 3 right here and the whole angle are not adjacent to each other. You cannot overlap them. Okay? Vertical angles are 2 angles whose sides are opposite rays. Essentially, vertical angles happens when 2 straight lines intersect, which you can see from the picture. So vertical angles, angle 1 and angle 2 are vertical. There's a straight line right here, and there's a straight line right here. Okay, they've intersected each other. Angles 3 and angle 4 are vertical angles. Okay. The other 2 are 2 angles you've seen before, you've talked about before, I'm sure. Complementary and supplementary. Complementary angles are 2 angles whose measures have a sum of 90. Each angle is called the complement of the other. So in other words, here as we look, you have a picture here. Angle 1 and angle 2 added together is going to equal 90 degrees. Same thing here. Angle A and angle B added together are 90 degrees. They are complementary if they add up to be 90. Supplementary angles are 2 angles whose measures have a sum of 180 degrees. Each angle is called the supplement of each other. So in other words, angle 3 plus angle 4 is 180. It forms a straight line. Okay? Those 2 angles add up to be 180. Okay? All right, so as we're looking at this, let's do some examples here. Use the diagram at the right. Is the statement true, and explain. So angle BFD and angle CFD are adjacent angles. So what I'm going to do here is I'm going to outline these in a thick pen, and we're going to go with 2 different colors, blue and red. So angle BFD is this angle, and I'm going to erase that here. So we've got angle BFD, and let's make this a little bit bigger here. So angle BFD is like so. That's BFD in red, in blue. And in red, we're going to take CFD. Okay, so CFD. Are these adjacent angles? As you look at these, again, they should not overlap. You see that the blue angle overlaps onto the red angle. They share a side, but the side is not the side in the middle. It's the side on the end. Okay? So these guys are not adjacent angles. There's a no there. They're not adjacent angles. Okay? So let's take a look at letter B. Angle AFB and angle EFD. I'll do the same thing. AFB. AFB is in red. That's that angle. EFD is in blue, and it's that angle. Okay? They're vertical angles. Are they vertical angles? That's what we're trying to determine. Okay, so as you look at this guy, you'll notice that this line, this is right here, this breaks off. This is not a straight line. So because it's not a straight line, these are not vertical angles. This is false. They have to be 2 straight lines. Okay? So, as I look at Now, the example C, AFE and BFC are complementary. So let's take a look at AFE. AFE right here. And BFC. BFC is right here. Okay? So, AFE is 62 degrees. So, AFE is 62 degrees. And BFC is 28 degrees. In order for them to be complementary, they have to add up to be 90, and they do. So this is complementary. This is true. They do add up to 90. Okay? So for part of your problems at the end, make sure, I want to have you do these next three and see if you can figure those out. Okay? All right, let's continue on here to finding information from a diagram. There are some relationships that you can assume to be true from a diagram that has no marks or measures. There are other relationships you cannot assume directly. For example, you can assume, okay, so these are important. You can assume that angles are adjacent. You can assume that angles are adjacent and supplementary, so they're right next to each other and they add up to 180 degrees. You can also assume that angles are vertical angles, okay? You cannot assume, in other words, these must have markings. If they don't have markings in the picture, you cannot say that they're true. For example, angles or segments are congruent. They're not congruent if they don't have the markings. An angle is a right angle. Again, if it doesn't have the marking, it's not a right angle. Angles are complementary. Again, if it doesn't have the marking, if they're complementary, they add up to be 90. You should see the square in the picture as well. Okay, so we talk about the next postulate here. It's what we call the linear pair postulate, and it says if two angles form a linear pair, they are supplementary. In other words, if two angles form a linear pair, they add up to be 180 degrees. So we're going to put that in there. They add up to be 180 degrees. Okay, so in this case, angle ABD plus angle DBC is going to equal 180 degrees, which is this part, left part plus right part is going to equal 180 because it's a straight line. Okay? All right, so as we look at some examples here, it says, what can you conclude from the information in the diagram? Well, I've got a couple things that I can conclude. Now remember, there are certain things that we can conclude that have to have markings and don't have markings. For example, I know I can conclude that angle 1 is congruent to angle 2 because, again, they have the markings here. Those two guys are equal. Okay? I can also conclude vertical angles. So angle 3 and angle 5 are vertical. Okay, angle 3 and angle 5 are vertical. I could say also adjacent angles. Angle 3 and angle 4 are adjacent. I could also say that angle 4 and angle 5 are supplementary. They're going to add up to be a straight line, add up to be 180 degrees. Could I say that angle 1 and angle 2 are complementary? No, because I don't see a box right here where it should be. Okay? Those are just a few of the examples of things that you can conclude. Okay, let's go through another example here in terms of conclusions. Remember, you have to have certain things here as we go through. Okay, so can you make each conclusion from the information in the diagram? Explain. Segment TW is congruent to segment WV. As you look at the diagram, does the diagram have markings? It sure does. TW and WV have markings. This is true. You can conclude that information. Can you conclude that PW and WQ are congruent? Do you have markings? No. So therefore, you cannot conclude. You do not have enough information here. Okay? How about TWQ? Angle TWQ is a right angle. Is there a marking here for a right angle? No, there's not a little box here. If there's not a little box, Nope, you cannot conclude that. Cannot conclude that that's a right angle. Can you conclude that TV bisects PQ? In other words, TV, this line right here, cuts PQ in half, which would mean that these two parts are equal. In the picture, does it show that these two parts are equal? No, it doesn't, because it doesn't have the markings. So no, you cannot, there's not enough information there. You're going to have to go through and do this today on your homework and be able to figure out what can I conclude without a marking, what can I conclude with a marking. Okay, last part of section 1.5 here. I want to go through one example. I'm going to set it up and then I'm going to have you complete it here. It says here, angle KPL and angle JPL are a linear pair. In other words, they form a line. If KPL is 2x plus 24 and JPL is 4x plus 36, what are the measures of those two angles? Well, if they form a linear pair, remember, they add up to be 180. So I'm going to set this up, 2x plus 24 plus 4x plus 36 equals 180 degrees. So in other words, this part, left part, plus right part equals 180. Okay? And what I want you to do is I want you to solve for the variable and then substitute in. It's very similar to the angle addition postulate. Okay. I also want you to take a look at this problem right here. Okay. Take a look at that problem as well and see if you can figure out the measure of angle PQS. All right. Okay, so this concludes section 1.5, part 1. Make sure you finish your WSQ at the end of this and also conclude the problems I'm asking you to conclude.